All right, this is lesson 3.8, the unions and intersection of sets. You will be able to find the unions and intersections of sets after you do this lesson. Vocabulary review, whole numbers less than 1, elements of that set, or whole numbers less than 4 would be 0, 1, 2, and 3. Even numbers between 1 and 9 would be 2, 4, 6, 8. Two sets are disjoint when they have no elements in common. Are the sets in 1 and 2 disjoint? No, they have the number 2 in common. And we call that the elements that are common to both sets, the intersection of the two sets. That's one of the things we're going to learn about. Intersection, the union is the other thing we're going to learn about. The union of two or more sets is a set that contains all the elements of the sets, all of the elements. The intersection of two or more sets is a set of elements that are in all of the sets. So intersection common to both, union in either one. And the symbol U means union. The symbol U upside down means intersection. So if our set A is a penny, a nickel, and a dime, and B is a nickel, a dime, and a quarter, those elements that are in either set A or set B, that's called the union. And that would include the penny, the nickel, the dime, and the quarter. Those elements that are common to both sets, that would be the nickel and the dime, and that's known as the intersection. All right. So, right, union or intersection. Union, remember, can be in either one or the other. Intersection has to be in both. So, cheese, milk, yogurt, apple, banana, pear. The set apple, banana, cheese, milk, pear, yogurt, that's in either D or F. Sometimes, and we'll use the symbol, sometimes people will even say D or F, but it really means the union of sets D and F. And the second one says cheese, milk, yogurt, bread, cheese, egg. The set cheese, that is the one item that's common to both. And sometimes we say D and M, but it really means the intersection of sets D and M. If the sets have no items in common, then the intersection is the empty set, and that's what we see here. F intersects M. Apple, banana, pear, bread, cheese, egg, they have nothing in common, so the intersection is the empty set. All right. So problem 1, union of sets. Suppose that in a box there are a brush, a marker, and a pencil. In another box there are a calculator, a marker, ribbon, and a brush. What items are in either box or in both boxes? Okay, and the items in either box, that would be the union. And we can see here that in either box, we're going to need a brush. We're going to need a marker. We're going to need a pencil. Essentially, we'll need everything from the first box, and then anything in the second box that wasn't in the first box, which is a ribbon and a calculator. So that box represents the union. All right. And both sets, what's common to both, we see that we have a brush in both of them. So we'll put that in this one. And we also see a marker common to both, so we'll take one of those. And that is known as the intersection. All right. So write sets P and Q below in roster form. What is P union Q, or and we can say P or Q, and either P or Q. So the symbol U means union. Set P is a whole number less than 5. That would be all of these except 5. Write this in roster form 0, 1, 2, 3, 4. Circle the numbers and set Q. Q is why is an even natural number less than 5. Natural numbers start at 1, so that would give us 2 and 4 in roster form. Okay. The union of the two sets would include every item that is in either P or Q. That would be 0, 1, 2, 3, and 4. All the items that are P. Q gives us 2 and 4. That's nothing new from what we have in P. What is it true about the union of two distinct sets if one set is a subset of the other? What is true is that the union is the larger of the two sets. All right. The intersection is a set of elements that are common to both. Disjoint sets have no elements in common. The intersection of disjoint set is the empty set. So let's try this one. If x is a whole number less than 15 and set y is all numbers such that y is an odd integer, and z is all numbers such that z is a multiple of 4. What is x intersects z? So x is a whole number less than 15, so that's 0, 1, 2, all the way up to 14. And z is anything that's a multiple of 4, so that's 4, 8, 12, 16, and so on. That keeps going. So x intersects z would be any items that are in x, so these, that are also in here. And so we really only need to worry about these. And so the first 3, so, and we'll write that in roster form. X intersects z equals this set 4, 8, 12. Okay, what is y intersect z? Y intersects z. So y is, that's all odd integers. All odd integers. So y looks like, so once again, y is any odd integer, so that looks like this. And z is a multiple of 4, so 4, 8, 12, 16. There are no odd integers in that set, so the intersection, these two sets are said to be disjoint, so the intersection is the empty set. And we can show that like this, or we could use the symbol for empty set, which looks like that. All right. All right. So C is n such that n is an odd whole number. A is 2, 4, 6, 8. B is 0, 2, 5, 7, 8. The symbol upside down U means intersection. The numbers 2 and 8 are in both sets A and B. So A and B, or A intersect B, is the numbers 2 and 8. A and C, or A intersect C, and write, so A intersect C would be, those common to both. If n is an odd whole number, then if we look at A, we notice there are no odd numbers in there. So A intersect C is equal to the empty set, and C intersect B, that would be odd whole numbers, And we have a couple odd whole numbers in B, so that would be those two numbers. The intersection is 5 and 7. So what is true about the intersection of two distinct sets if one set is a subset of the other? The intersection is the smaller of the two sets. All right, three friends are learning new languages. Draw a Venn diagram to represent the union and intersections. Which language do all three friends have in common? So Matt has Spanish, German, and Italian. Let's put that over here. Matt has Spanish, German, and Italian. Okay. Rob has Spanish and German. Rob has Spanish and German. And Jane has Russian, Chinese, and Spanish. Russian, Chinese, and Spanish. Now, we noticed that all three of them have Spanish, so we need a part of the Venn diagram that have all of them. And we also noticed that Rob has, and Matt both have German. So we're going to put that in a place that Rob and Matt have in common. And that's what that Venn diagram would look like. All right. So what do all three friends have in common? That would be Spanish. All right. So making a Venn diagram here. So if we want, let A equal X such that X is one of the first 5 letters of the English alphabet. So that would be A, B, C, D, E. And B is all X such that X is a vowel, A, B, and O. And then C is a letter of the word vegetable, which letters are in all three sets. So vegetable. So we need all those letters to make vegetable. The letters that are in set A but not in any other set are running out of time, so I'm going to have to pause it. All right, so using the Venn diagram, of 125 students in 5th grade, some have music on Tuesday, some have art on Tuesday, some have both on Tuesday. 68 have music on Tuesday, and 33 have both on class on Tuesday. How many students have art on Tuesday? So since we know 33 have both, let's put them right here in the middle. We know there are 68 that have music, but of those 68, some have both music and art. So let's track those and figure out how many are just music. We know there's 125 total, so that means that 125 minus 68 would equal the number that have art only, which is 57, because all three of these have to add up to the total. And so now we want to know how many have art on Tuesday. That would include the ones that have both on Tuesday plus the ones that have art only. So 57 plus 33 equals 90. I have to pause at this point, and there'll be a second part to